Okay, so in this we can talk about elementary level of mean, median, mode, and Boston Whisker Plot, stuff like that, and very small factoring. So that's what would be in this thing. So the mean is basically the average. I think we've seen that in many cards. It's whenever someone says, you know, like what's the average? If you scored a 0 on a test, for example, and if you scored 100, the average would be 50 because it's in the middle, kind of. It's just the average. The mean of numbers. The median is going to be the middle of the. It's got basically the middle of a sorted list of numbers. So if you have 2, 3, and 4, suppose the median is, I just like to cross off each end until you get to the middle. So the median is 3, which is the middle of a sorted list. So remember, low to high, sorted list. That's very critical. You can't just do that for any list of numbers. You should have it sorted. Mode is the numbers that appears most frequently in like a list, for example. So like 1, 2, 2, 4, 4, 5. In this case, it's 2 modes actually because it's 2 and 4, but if it's like 2, 2, 3, then the mode is 2. Yeah. Whatever, it can be more than one number, you know, they occur the same amount of times. But yeah. Okay, let's do the real quick example. Find the median of this. 1, 2, that's not right. 1, 2, 4, 6, 4. So again, first step is always to sort them. Yeah, if you do the sorting, you get 1, 2, 4, 4, 6. And you do this until you get to 0. In this case, it actually did not matter, but this is a pure coincidence. You should sort your list. So that means the median is 4, and you can move on. All right, let's do the arithmetic mean, or the mean of these numbers. I'm going to list them out. In this case, you don't need to put them in sorted order. For mean, you just add them all up and divide it by the number of numbers that are in the list, I guess. So suppose 8, 10, 8, 5, 4, 7, 5, 10, and 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's 9 numbers that will help with stuff. So you could just literally add all the numbers and divide by 9. That's in essence how you find it. So I'll just write the mathematical equation. 8 plus 10 plus 8 plus 5 plus 4 plus 7 plus 5 plus 10 plus 8. Basically all of them divided by 9. And if you do end up doing the math, you get this is 65 in the top and divided by 9. So your answer is going to be 65 over 9. You can leave it as a fraction. This doesn't go into easily. Yeah. Mode. Let's do that of these numbers. 4, 9, 6, 3, 4, 2. Let's see what number proves most. It's 4. Yeah, twice, and no other numbers proves twice, so 4 is your answer, and we'll move on. Okay, okay, we want to find out, we have this list of numbers, 11, 12, 7, 3, and then there's one more number, we don't know the number, but we told the mean, which you also actually sometimes see written as this in statistics, is 8. Yeah, it's 8. But so we want to find out what this is. Suppose that's an X, honestly. We don't know what it is. So it's the same equation. You add up all the numbers and divide by the number of numbers to find the mean. How many numbers are there? 1, 2, 3, 4. And you include this one because you wanna, that's the mean including that number, so 5. So it's basically the way you would find this, or set up the equation for it. 11 plus 12 plus 7 plus 3 plus x, because that's the number we don't know, but we want to include it because the mean that they gave you, 8, includes that number. We have all that divided by 1, 2, 3, 4, 5, and that's going to equal 8. Oops, yeah. And then you just do, at that point, it just becomes a math equation. So you can do times 5, get rid of that. So you get 40, add all them up, and then do 40 minus whatever this equals. Yeah, so you're going to end up getting that x equals 7 if you do that math, which is just adding and subtracting and stuff like that. Actually, no subtractions, but just math. So you end up finding that x equals 7 as your answer. right, let's go on to talk about the box and Whisker Plot. Okay, so let me just draw it out. That's not how you. It's a box and Whisker. Why is it called that? Because let me draw an example. It kind of, I guess, suppose it looks like a box and whisker in a sense. You do like this, like that, kind of like a box and whisker. So this is a minimum value. So you basically draw this and write the numbers above it, in essence. That's that's minimum of the list of numbers. This is a median because it's in the middle of a sorted list, remember? Sorted, that's very important. That'll be the first step usually. This is a max. This is called quartile 1 and quartile 2. And with the lower quartile and the quartile 1 and quartile 2, 3 actually, not 2. Quartile 2 is actually the same thing as median. Why? Because this is split up into basically quartiles. This whole thing is the first quartile. This whole thing is the second quartile. This whole thing is the third quartile and the fourth quartile, or the whole thing. So yeah, quartile 1. Yeah, so you're gonna have so min Q1, quartile 2, but quartile 2 is known as a median. No one really calls it quartile 2, I guess. This is quartile 3, and that's a max. Yeah, so let's do find all these values. Let's see, there's one more value, which is called the interquartile range, or IQR for short. Interquartile range, which essentially means what's the range of the interquartile, like the inner quartile, which is quartile 3 and 4. So the way you find this IQR is just Q3 minus Q1. So find all these values, and then you can find find those values, find the IQR, and then you just literally draw the structure like that and put the numbers above it in essence. So I'll just work on finding the values because that's really the important part. Okay, let's get all the values that we need. Let's suppose this is the list of numbers we have been given. 22, 37, 14, 42, 15, 53, 25. So these are all the numbers we've been given. Just as a note, to find quartile 1 and quartile 3, you would quartile 1 is basically the median of the lower half, and quartile 3 is the median of the upper half when you put the list in sort of order. So let's do that first. That's important. I'm just gonna do it because that's it's just, you just look at it and do it. 5, 7, 12, 14, 15, 22, 25, 30, 36, 42, and 42, and 53. Okay. Let's just find the median. It's gonna be what? Yeah, it's gonna end up being 22, which is the median. So I'm just gonna do this so we can go on this because the median is 22, and that is really helpful because we know the middle value. So that's the median. We had 5 values, right? That we need to find. Min, let's just look at it. It's a sorted list, so 5 is the minimum. Quartile 1, we don't know yet. Median, or quartile 2 is 22. Q3, we don't really know yet, maybe. And then the max, which you do know, which is the end of the list, so 25. And once you know Q3 and Q1, we can find the IQ. Okay, so Q1, quartile 1, to find that, you look at the median, look at everything to the left, and you find the median of that. So it's basically the median of this, which is going to end up being, let's see, cross that out, 12. So that's 12. And then the quartile 3, you look at this stuff and find the median of that. So 1, 2, 25. Oh, this is 53 here. I forgot. So 1, 2, 3. I'm just gonna write the right half again because this is a median we have. That's 22. And then we have 25, 30, 36, 42, 53. Oh, wait, you don't include the median. Sorry. That. So that's gonna be 36. You can't tell us 36. That's 36. Okay. And then to find the IQR, which is the middle value, like the range of the inner quartile to the middle, I guess, which is Q3 minus Q1, which in this case Q3 is 36 you found, Q1 is 12, which is going to be 24, and that's your IQR. Okay, that's basically your box and Whisker Plot. Okay, let's quickly talk about factoring, which basically just means, if you have 5 times 4 equals 20. These are the factors, 5 and 4. That's it. So let's factor some stuff. It can get harder with with variables as well, instead of just numbers. 91. I'll just tell you this is easy. 191, 7 and 13. Why? Because 1 times 91 is 91. 7 times 13 is 91. 13 is 91. Yep. Okay, let's get a little bit tricky. 20x. That's 20x. So 1 and 20x are obviously factors. So in this case, 5 and 4x are also factors because 5 times 4x is 20x. So that means 5x and 4 is also a factor because that also equals 20x. You have 2x, 10, that gives you 20x. You have 10x and 2. So these are some factors of 20x. Well, it gets a little bit harder with variables. So for instance, 25 x cubed. Okay, this one is going to be a good amount. So 125 x cubed. That's cubed. You have 5. Oh, that's not a 5. 5 times 5x cubed. X cubed times 25. You have x squared. X squared times 25x, because 25 times 25x times x squared is 25x cubed. And you have x and 25x squared. This is going to get messy, but it's basically go down the list and find the factors. What things give you x cubed, which is it's x times x, x squared times x cubed times x. Actually, not x cubed times x. It's x cubed times 1, I guess, which is x cubed. Yeah, those are some options. So yeah, that's why it's a little bit tricky because you have a bunch of ways to get x cubed, and also in this case, a bunch of ways to get 25, and you just combine them. So these are some; they're not exhaustive, but that's how you find them. Okay, I'll list out some for 30x squared. That's x squared. Okay, 1, 30x squared, 2, 15x squared. Yes. 2x, 15x, 2x squared, 15, 3, 10x squared, 3x, 10x, 3x squared, 10, 5, 6x squared, 6x, 5x, and 6x squared, and 5. Yeah, so those are some of them. It's very hard to read, but again, you would just find out what gives you x squared, which can be x times x, or just x squared times 1. And then you find out ways to get 30, which there's a good amount, and you combine them. Yeah, so that's how you do factors, and that will conclude this portion. Thank you.